You absolute legends. Take a moment and look at these two Lewis dot structures of CO2, carbon dioxide. Look at them carefully. Pause. Now you'll see I kind of made a little error, so to speak, with this one here. Now, what I ask you to consider the following is that we have been drawing Lewis dot structures with two major criteria points: the total electron count and the octet of each element. Now, in CO2, carbon dioxide, the total valence electron count is 16 electrons. And these both fit that criteria. 16 electrons in here, 16 electrons in here. The second criteria was octets. Each element has ocho, or an octet of electrons around it. So which is better? Now, if we Google it, we can see that, okay, the carbon's in the center. This is the one that comes up on Google. Just the name itself, CO2, carbon dioxide, does give us an idea of what's in the center there, the carbon. But we can use a calculation or a third criteria called the formal charge to determine that this is a better picture or cartoon image of carbon dioxide. So our three criteria now are the total electron count, the octet, and the formal charge of each of these atoms. Let's talk about how to do the formal charge calculation. It's a really simple calculation, but it's really easy to mess up because it's complicated. It's just like all over the place right here. So before we get started with doing a formal charge calculation, our ideal formal charge for every individual atom, so we're going to do 6 calculations total. Each one we want to be 0. We want the formal charge to be 0. If it's not 0, we want it to be just +1 or -1. Like we want it to be in a kind of a very close frame right there. If any atom comes up as negative, it should be the most electronegative atom. And if any atom comes up as positive, it should be the most electropositive atom in there. But we want our atoms to be 0. So let's do this calculation here. So for carbon, let's do the central atom here. Carbon, this central atom. Now to do the formal charge calculation, the first thing we need, I'm just going to abbreviate it, FC. Here's our kind of skeleton for the formal charge calculation here. Now, I'm going to talk about what goes in these 3 spots here in a second. So we are doing it for this carbon atom right now. The first thing we need is our periodic table. We are going to find carbon on the periodic table and get the number of valence electrons that carbon brings in the periodic table. We do this calculation to do the total electron count before we draw our Lewis dot structure. So from the periodic table, carbon brings 4 electrons from the periodic table. That's how we get this 4 here, specifically for carbon. Now, this one right here, we use the Lewis dot structure. In this one here, we look at the atom carbon and look at all the electrons that are in lone pairs. In this picture, for this carbon atom, carbon doesn't have any lone pairs of electrons, so it is 0 electrons in lone pairs. Let me do this bracket here. This one we get from the Lewis dot structure. These 2 items we get from the Lewis dot structure. Now this number here that we get from the Lewis dot structure, we're going to divide it by 2. We look at the at that atom and see how many bonds it has, how many electrons it has in bonds. Its octet, 1, 2, 3, 4, 5, 6, 7, 8. All 8 of its electrons are in bonds. And we're going to take that number 8 and divide it by 2. So 4 minus 0 minus 4 equals 0. So this central atom here, carbon, has a charge, has a formal charge of 0. Let's do that same calculation for this oxygens. Remember, we want all the formal charges to be 0. So now we're doing it for this oxygen here. Can we agree real quick that these oxygens are in identical situations? They both have 2 lone pairs, and they both have 2 bonds. So if we calculate the formal charge for one, we're going to get the same number for the other one. They are in what's called isoelectric situations. Iso meaning the same or not changing. Isoelectronic situations here. So by finding this oxygen, or finding oxygen on the periodic table, oxygen brings 6 valence electrons. And now from the Lewis dot structure, how many lone pairs are on oxygen? There are 4 electrons in lone pairs on oxygen. How many electrons are in bonds? There are also 4 electrons in bonds. So 6 minus 4 minus 2 equals 0. So this oxygen has a formal charge of 0. This oxygen has a formal charge of 0. This is looking pretty sweet right here. Now this structure of carbon dioxide, remember, it fits our criteria. The first 2 points. It has the total, it has 16 electrons total. Every element has an octet. Let's check its formal charges. If the formal charges of each atom are all 0 across the board, then this is a good structure for CO2. Let's check and see if it is. Let's move left to right here on calculating this. I'm calculating the formal charges. Let's calculate the formal charge of that oxygen there. Starting with the periodic table, 6 electrons. Looking at the Lewis dot structure, it has in lone pairs, it has 4 electrons. And looking at the Lewis dot structure of bonds, it has 4 electrons in bonds. So 6 minus 4 minus 2. This also has a formal charge of 0. Let's calculate every atom. So this oxygen here, finding oxygen on the periodic table, again, has 6 valence electrons. Notice that because this number comes from the periodic table, if it's oxygen, it's always going to be the same number, 6. If it's carbon, it's always going to be 4, because this is from the periodic table, the valence electrons. These numbers change depending on the Lewis dot structure. So for example, this oxygen atom has 0 electrons in lone pairs on the Lewis dot structure, and it has 8 electrons in bonds. So 6 minus 0 minus 4, this gives us a charge of plus 2. 6 minus 4 plus 2. This is not looking good so far. Let's do the last element, carbon in this one. Carbon in the periodic table is going to have 4 valence electrons. We're doing that carbon there. The number of electrons in lone pairs is 4. The number of electrons in bonds is 4. So 4 minus 4 minus 2, that carbon has a -2 formal charge. When analyzing two Lewis dot structures, we have 3 criteria to consider. The total electron count, whether each element has an octet, and the formal charge. We want elements to all have a formal charge of 0. Thank you.